A client hands you a single domain and says go. How do you turn that into a complete map of their attack surface? DNS enumeration. It is the single most productive recon technique I use, on every engagement, without exception. On one test, a single domain became over 200 subdomains, and a forgotten Jenkins staging server on one of them was our way in. Today, day 5 of this challenge, I am walking you through exactly how to do this. Let us start with manual queries using dig. You want to pull specific record types because each one tells you something different. A records give you IPs. MX records reveal mail infrastructure, which is often hosted separately from web servers, that is a different attack surface. NS records show you who manages their DNS. TXT records are where it gets interesting. SPF entries in TXT records literally list every IP range authorized to send email for that domain. That is a free infrastructure map. SOA records contain the primary name server and an encoded admin email address. Replace the first dot with an @ sign. The serial number sometimes uses a date format, which tells you when DNS was last changed. Start with digtarget.com and then the record type MX, NS, TXT, SOA, with the plus short flag to strip out the noise. Also query Quad A records for IPv6 addresses. Many organizations apply strict firewall rules on IPv4 and forget to mirror them for IPv6. Now the zone transfer. AXFR is a mechanism for replicating DNS between name servers. If it is misconfigured, anyone can request the full zone file. You get every DNS record in the zone, every subdomain, every name, everything. Run dig at each name server, the target domain, then AXFR. Most of the time it fails externally, but on internal engagements, I find it works more often than you would expect. On one test, a secondary name server hosted by a third-party provider was still allowing AXFR even though the primary was locked down. That gave us 40 internal subdomains including VPN, GitLab, and monitoring endpoints. When zone transfers fail, and they usually do, you go passive. Passive DNS collection queries databases of previously observed DNS resolutions without touching the target at all. Subfinder is my go-to tool. It pulls from certificate transparency logs, VirusTotal, Shodan, and other aggregators. Run Subfinder with the D flag for your target domain, output to a file, and then pipe that file into httpx. httpx resolves each subdomain and shows you the HTTP status code and page title. A title of Jenkins or Grafana or Swagger UI tells you exactly what to investigate next. This passive approach found subdomains on every engagement I have run, and it generates zero traffic to the target. Active brute forcing comes next. Tools like dnsenum and amass can guess subdomains from word lists. The word list quality matters more than the tool. SEC lists has good general-purpose lists, but supplement them with terms specific to the target. If they use Kubernetes, add terms like Kubernetes, Ingress, and Istio. If they are a Java shop, add Jira, Confluence, Nexus, and SonarQube. One critical step before brute forcing: test for wildcard DNS. Query a random garbage subdomain like AXFR.target.com. If it resolves, they have a wildcard record, and every single brute force guess will appear to succeed. You need to filter your results to exclude that wildcard IP address. Subdomain takeover is a finding that comes directly from DNS enumeration. It happens when a name record points to a third-party service that no longer exists. For example, a name pointing to a Heroku app that was deleted. If you can create that Heroku app, you now control that subdomain. Collect all name records from your subdomain list, then check if the targets resolve. If you get nextdomain on the name target, that is a potential takeover. Common targets include GitHub pages, Heroku, AWS S3 buckets, CloudFront distributions, and Azure services. Here is my complete methodology, in order. First, manual dig queries for all record types. Second, zone transfer attempts against every name server. Third, passive collection with subfinder and amass in passive mode. Fourth, wildcard detection before any brute forcing. Fifth, active brute forcing with a tailored word list. Sixth, resolve everything with httpx to find live services. Seventh, analyze names for subdomain takeover. Steps 1 through 3 are quiet. Steps 4 through 6 are noisy and detectable. The output of DNS enumeration feeds into everything that follows. Tomorrow on day 6, we cover web technology fingerprinting, and we will be running that against every subdomain we discovered today. The subdomains that get overlooked, staging servers, internal tools, abandoned deployments, those are almost always the weakest. Your subdomain list becomes the most referenced document for the rest of the engagement. Save it, organize it, keep it updated. That is day 5. Practice this on a domain you own or a bug bounty target, and I will see you tomorrow.